Hello everyone and welcome. In this video I'd like to go through the first sample case in the manual, the DocMicMac PDF. The Vincennes dataset has a link right here in the PDF file where the files can be downloaded. And they say the goal is to achieve a typical architectural task, compute for each of the main facades, and orthophoto. In this set of videos, or this video, I'm just going to go through the facade number 1, the photos, the name of face 1. This is the images that were taken. It starts out with a set of calibration images. Then there's the face 1 images, all taken in order, left to right, and then they create some link images, which is an intermediary between the face 1 and face 2 images. And then they do the face 2 images, also left to right. Also included is this text file. It gives a list of all the commands that you would run in a terminal to get the final result. And it also includes ground control points within these files here. Open that up, take a look. Actually, this is for a different set. This is for the scene-based orientation. This is the measure test images file. And there it is. It has the ground control points with X, Y, and Z values and names for the points. Okay, enough for the introduction. Let's get started. So I'm going to go to Start, and I'm going to clear any previous files, and I'm going to copy the images. Vincennes, select all the images, and open. And I found a 35mm equivalent in the file, so they can be used as is, even though they weren't found in the databases. I'm going to make one change. I'm going to uncheck minimize command inputs, and that just expands to show the commands that are actually run in the terminal in the background. And I'm doing that because I think there's a bug and I want to check it out later. So I'm going to go to the tie point matching, Tapioca, and start with the calibration images. So I'm going to clear the selection and then select the calibration images. The left click and shift left click. And I got 12 images, that's how many there are. And the instructions say to run all. Scale is going to be 1, image size is going to be 1000. And everything else is good, so I'm going to go ahead and run that. Okay, that's it for calibration images. Close that. And before I do some more, I'm going to go back to Start, and I want to open up a file browser. To the temporary folder, shows where all the images were copied. It also shows that the images' names, the dash was removed from them. Okay, that's Calib.img, and the original files had Calib-img. Just wanted to make that note because I'll need to edit some files later to match the change. All right, back to it. I'm going to go back to Tapioca and do the next set of images. I'm going to clear the selection again and choose all the Face 1 images. And since all those images are taken one after the other in a line, I'm going to change the mode to line, set the image size 1000 to match what's in the book, and a delta of 5. And go ahead and run that. Okay, that's done. Face 1 images. I'm going to clear the selection again and do the Face 2 images. Okay, all the same settings, line, image size 1000, and delta of 5. Okay, this computer is running it fairly slowly, so I'm going to go ahead and pause the video at this point and come back when it's complete. Okay, it's done. The final set of time matches will be the link images and a few of the Face 1 and Face 2 images to tie them all together. So then once again, I'll clear the selection. I just select the link images. And I want a few images to either side of it. I want the Face 1 starting at 5290. And Face 2 ending at 5319. Okay, for this one, change the mode to all. So I have all, image size 1000, and run it. Okay, and that's it for the final type point calculations. I'm going to go on to the Topaz step. Let's find out what the instructions say. We want radial standard for the mode. want just the calibration images for the first run. I'm going to set my operation to calibration. And run it. Okay, that's done. Got green all across the board, so it's looking good. Calibration is complete. So I'm going to choose Orient Final to feed that calibration result into the final result. I'm going to invert the selection so everything is selected except for the calibration images. And I'm going to make a change on my computer. I don't want it to go to sleep. This process takes about half an hour on a computer faster than this one. I'm going to set it so it doesn't go to sleep and mess me up. All right, back to it. Again, it's radial standard. Calibration feeding into all. And everything's selected except for calibration. All right, start that process off. I'm going to go ahead and pause and be back in maybe about 45 minutes. Okay, Topaz is done. The results looks good. Everything's green. And it ran much faster than I expected it to. So that's good. So next I'll create a 3D preview. And let's see what their guidelines say about that. Selecting everything except for the calibration images. So no change in the selection. Paracloud and run it. And it's done. You can close that and take a look at the result. Okay, there we have it. We have all the Phase 1 cameras going in this direction. And we have the Phase 2 cameras going in this direction. And then it mixed up with the link cameras. Okay, the result is reasonable. At this point, the instructions say you can either do a ground control point based absolute orientation or a scene based orientation. So I'm going to go head to the ground control point and use that as the next. So I'm going to open the XML file that contains the 3D measurements. My Vincennes dataset. And I want the 3D measurements. So open that up. It brings in all the measurements here. Now I want to create the measurement files. And just save and close. Now at this point I want to edit the file. Here I'm in my MicMac temp folder. Here's the two files that were created. I'm going to edit the XML file. No, actually, I'm mistaken. I don't need to edit this file. It's the 2D file that needs editing. So I'm going to go ahead over here. I'm not going to import it as the final file. And when I change this, uncheck that, import the 2D measurements file. Go back to my photogrammetry folder, the Vincennes dataset, and I get the 2D file. File's been copied, it may need editing, and in this case it does because of the file name change. I go into my temp folder again. There's the measurements 2D that was just copied. I'm going to edit that. Find face 1 dash. I'm going to replace that just face 1 and replace all. And I'm going to do the same thing for face 2. And here's a couple of face 2s, replace all. Close that, save it, and now we're ready to go forward. Again, I had to get rid of the dash because this front end removes the dashes from the names, so it has to match up. And because the measurement files were imported, don't need to select any points. I'll just run the initial points. Yep, all but the calibration images are selected. I'm going to run the initial points. And done. And because I ran the initial points, over here in the final step is set up to use that the initial points as the final. I can go to validate points, and I can see where the points were created. And that brings in the points. And we can see the points in the images here. Now there's no documentation for how the points are, so there's no need to go in and validate everything. Just going to skip that part. So exit, close. Now over here on run compare, it's already set to use the initial 2D points since we never processed any final measurements. And I'm going to set that just as it is. The same image selection, the face 1, links, and face 2, and run that. And it's done. Close that. And the next step is to create another 3D preview to be sure all the orientations came out okay. So I'm going to jump to the pair cloud using this button. And you can see here at the top, the orientation in is from the compare out that was just run. So I'm going to run a 3D preview. Okay. So that. And we can see here that everything is right side up now. This blue line is the Z-axis. And the green and red and green, that's the X and Y, which represents the more or less the ground direction. I'm going to show the ground control points just to see what that looks like. Go in and select the 3D measurements file. And make it a little bigger in the name size. Okay, there they are. If we knew where the ground control points were supposed to be, that could be another check to be sure that everything processed okay. I'm going to go ahead and turn that off. And I'm going to make a mask that includes only these two walls, so I don't have any of this extra junk out here getting in the way. So I'll press the Make 3D Mask button. And bring it into their tool. Now middle mouse zoom inward. Go to Selection and Point Selection. And just click with the mouse to get the two faces, or the two facades. Right click to close. Spacebar to select it. Now I can save that selection info. And exit. And now we're going to the dense cloud step, C3DC. I believe they have, let's see what they did in their instructions. Did they do that? Oh, right. They do it completely differently. So I'm going to say use MicMac, sort of a medium mode. I have everything selected except for the calibration images. And go ahead and run that. Oh, actually, I'm only doing the phase 1 images, so I'm going to only process this phase 1 images for this dense cloud reconstruction. So I'm going to clear the selection and only select the phase 1 images, which is what I want to use to create the final ortho image. Okay, got all the phase 1 selected. And as MicMac, I'm using the mask I was creating earlier, and create the dense cloud now. I think this will take about 5 minutes, so I'll go ahead and pause the video, come back when this step is done. Okay, 9 minutes later, and it's done. Close it and take a look at the result. Got about 600,000 points. And the next step is to create the ortho photo. I'm going to first do it without using this option here, both ortho-cylindrical, to demonstrate what happens with and without it. Apparently it's needed when you're processing like a circular shaped building, but it also improves the result if all your cameras are just in a single line, because that creates some kind of problem with the mathematics and gives an ugly result. So I'm going to do the ugly result first. No ortho-cylindrical, and run the Replok Bascule. And I get an error. Oh, because I forgot a step. Right here I need to create some masks on a couple of the images to define the z-axis so that the z-axis is facing out of the facade towards me instead of pointing straight up. So I'm going to come down, and there's two images that need masks. There's 5259. This guy here, so I'll click the mask button. And I'll just draw out a mask on the front face here. And space to select. File and save. And exit. Mask indicator shows. And I need to do it on one more image, 5291. That's here. Okay, do it again. Oops, I have it open twice. Let me close one of those. I'm going to again click to select the faces, right click, and space. Save that mask and exit. Now I can do the rep block bascule run. And good, it's working this time. And it's done. We'll close that. And after it finishes running, it checks the local repair. And have this in the command right here. That was something that I wasn't certain about, because sometimes I ran it once in a test and it didn't actually check the box. In any case, the next step is to run the PIMs to M&T. Okay, it's done. Close that. At this point, you have the option of saving a depth map, but I find that to be not all that useful, so I'm going to go ahead and run the Tawny step, which creates the actual image. All right, and the image has been generated. I'm going to go ahead and save it. I'm going to put it on my desktop. Make a new folder. Let's compare. Call that Vince. No sill. You can go ahead and take a look at that. Desktop, where are you? There you go. Okay, there it is. Got the final image here, and now I'll run it again with the ortho-cyl option to see if we get an improved result. So back in here, ortho-cylindrical, updates the command, and run the reflock bascule. Now I'll go ahead and pause until it's done. Okay, that's done. It ran much faster because of the previous run. I'm going to close that. Make sure I got the local repair. And run the PIMs to MNT. That PIMs to MNT is done. So I'm going to go ahead and run the Tawny to generate a new image. Okay, that's done. Only took about 2 minutes, and we have a new image. I'm going to save that. Call it Vince. Yes, cell. Let's go back here. I should be able to swip back and forth between the two. There's the cylindrical one. You can see it's been cleaned up. Don't have all those broken looking pieces. Go back and forth a couple of more times for comparison. Over on the right, got a lot of broken stuff there. And that cleans up with the ortho-cylindrical option. So if you have all your cameras in a line and you want to make an ortho photo, you should use the ortho-cylindrical option. And that completes the ground control point. Now I'll run through the process again using the image-based orientations. I'm going to copy the 2D file. I'm going to copy it from the original source. Samples, Vincennes dataset. And I want to measure mask face 1. I'm only doing face 1. File copied, may need to edit it, and yes, I do, because the names did change. Oh, that's where I want to be. And I forgot what it told me the name would be. I think it's this one. Yep, that's the one. Okay, I'm going to do what I did before. I'm going to replace all the face 2 dashes with face 2. And actually, there's probably only face 1s in this file. Place all this and save the file. By using this, there's no way to check where those points were actually defined in the images. This is if we've already run the define points button, but there's no way to look at it. So the next step is to do the masks, same as I did before, on the same 2 images. So it was 5291. right-click, space to select, save, and exit. And image 5259, which was the first one. And the same thing, mask the front of the building. Spacebar, save, and exit. Okay, now that I set the masks, I check ground from mask. I'm using distFS because EC1 and EC2 were defined in this file. There it is, there's EC1 and EC2 is elsewhere. So that means the distance is defined. And I can look at the original notes here. Let's see, they put that. Here it is, the section without GCP, without ground control points. They have a distance fs of 2, and they're using ij. I'll set that to 2. Change the ki to ij. And I'm going to select all the images, not just the face one. So I'll actually select all images and then deselect the calibration. Set, and I can run the calculate. All right, it's done. No errors, close that. And now I use Campari to apply all those images. But in this case, it would be just face 1 since that's what I'm interested in. So I'll deselect the face 2. Oh, no, I want all the images. That's right, all the images. And apply to run Campari. And it's done. Okay, can we close that? Everything is green and good. So now I can make a 3D preview. Okay, 40 seconds later and it's done. And come in here. You can see that Z is up and X and Y are in the ground direction. And from this point forward, it'd be the same steps as before in the ground control points. You go in, make a 3D mask. After the 3D mask is done, you go to C3DC to create a dense cloud and follow the exact same steps down to masking a couple of the images. Be sure to check Ortho-cylindrical because all the images are in a line. And then run the PIMS to MNT, then Tawny, and you'll get the same basic result as before. And that's the end of this video. Thanks for watching. Hope it was useful. Have a good day.